Good evening. Here we have another little kit that I've actually been sitting on for quite a while. It's a flashing police light type kit, and basically it's 3 boards of LEDs, and this is another one of those decade counters similar to the waterfall light, along with a 555 timer, I believe it is, with it. Yes, 555 timer, and it does the same sort of thing, but instead of counting 1 to 10, it actually goes sort of 1, 2, 4, 3, 4, 5, 6, 7, 8. It flashes the lights in alternating sequences so that it looks a bit like a police car light. Now, if I solder all this in one go, I think watching it live would be very boring. So I think we're just going to do these boards sort of. I'll start one off, then we'll do a cut to actually doing the main board once I've finished. Otherwise, just sitting here watching me soldering lots of LEDs onto a board might be rather boring, if I'm not too boring already. So what have we actually got in here? We have a resistor, which will be the current limiting resistor. We have a socket for the board, and we have 3, 6, 9, 12, 18 LEDs for this board, and it was all clearly marked out. Let's see if I can get it to focus in. Just press the focus button. We're going to focus for me. There we go. Nice and clear on that. Obviously everything in the background's now gone out of focus, but yes, clearly marked. Let's focus back again. There we go. As you see, it sort of disappears on the green of the background, but that's the colour of the mat I like working on. So I'll start soldering this up. I think we'll just do it nice and easy. We'll just put the LEDs in, and I'll probably solder them all in one go. I should really, in fact, before I put the LEDs in, actually test them before I put them in, and that way A, I'll know what colour they are. So these are blue, and B, I'll know they're working. I did actually make one of these quite a while ago, and for some reason it didn't like the transistors that were supplied with the kit, and I ended up using some rather large power transistors to replace them. It was just one of those things. So yeah, but anyway, so here we are, we're testing the LEDs. LED tester, eBay, less than £3, I think it is, and you can actually determine the amount of current that you put through it from 2 milliamps. That doesn't light. I think that, yeah, 5 milliamps. That doesn't light. Now, have we got a dead LED? Ah, there we go. Oh, there we are. No, it does light. Let's try it down here again. Yeah, it does light. As you see, it's not quite as bright. And if you go to the full sort of 20 milliamps, it's very, very bright. So there. It can also do common cathode type LEDs, where you have the common in the centre of the block of 3 at say 20 milliamps, or again going higher up to the higher current ones. Very good little tester, runs off 9-volt battery, and pretty much lasts forever. There we go. So anyway, as we're testing these LEDs, just put them in there. I don't know whether the fingers in it are starting to wear out, or if I got some dodgy LEDs. I'm putting it in the right way round. That might be a suspect one. I have actually had some suspect LEDs in the previous kit. That one's fully working, and it means that you end up changing them, but it's always a pain to change something after you've assembled it. You're much better off testing it all first if you can. You can actually do something very similar with resistor and a battery. Use a lithium battery, a 3-volt lithium battery, and a resistor that will limit your current depending on the colour. And you could do that, or a power supply with current limiting to about sort of 10-15 milliamps. You don't really want to go much higher than 15 milliamps. Not with sort of unknown LEDs. But you could, as I say, just buy one of these pieces of test kit. As I say, I find this one invaluable for doing this sort of thing. You just stick it anywhere, stick the LED anywhere in the top, and it works. So helps if you actually stick the LED pins into the circuit board. Getting past the flattened parts of the legs. How do I know which way round they're going? Well, the longer lead is normally positive, shorter one being negative, and again the symbol is the flat bar is your negative, as it shows on here, flat bar negative. And so you only need to really, once you've got the polarity sort of sorted in your head, it's just a case of clipping it in and figuring it out, and just getting into the routine of knowing which way round these go. So they're all in. Let's have another go with this one, just to make sure I'm not being a complete dunce. No, we look like we've got a dead one. So I shall, oh no, 30 milliamps has fired it up, and now it's working. It needed that initial current to get it to glow. See, now it's working on all of them. So, very strange. Again, I suppose part of that is the fact that it is an extremely cheap kit. So they're not going to use top quality high brand LEDs. They're just going to be cheap and cheerful. Stuff's fallen down in front of my cleaner. Stuff that's fallen down, actually I've got a pair of cordless soldering irons which I'm just going to use for work. Getting back to this, cheap and cheerful. Cheap LEDs, might even be factory seconds, which is why they didn't work initially. Again, I'm doing the one leg at a time trick. You could put a bit of tape on the back end, just to sort of evenly space them. What I'm going to do is I'm going to do the outer ones first, and then when I'm happy with the way they're sitting, I will trim the legs in and go to the inner pairs. That's that. So we'll just solder the other legs in, and then the board and the resistors. Now looking at this, you've actually got we got 1, 2, 4 in series, is that? 1, 2, 3, 4 resistors in series, and if you average for blue about 3 volts per LED, so it's looking for a 12 volt supply. So that will give you some idea of what the thing's going to run from. Obviously, you know, you can give it less voltage, but yeah, you will have a volt drop across the thing. Now, as I say, it's meant to be a flashing police light type simulator. So if you are going to put it in a car, your voltage can be anything up to sort of 16 volts coming off the alternator in the car. So we'll just do 1 pin, and then I can straighten it up. If I hold it like that, be able to put both in. Like so, and then we'll just sit it flat on the board. Okay, so there's 1 board done. Right, what I'll do is I shall come back once I've soldered the other ones up, and then we shall go through the main control part of the board. We'll see you in a few minutes. Okay, so now we're back. We have the 3 completed boards, those 3 little LED boards, and a pile of trimmings at the end. So that's that. So I think you've stuck around that long. We'll go on to this now, which is the main PCB. Now, there's a lot of components trying to escape the bag there. Let's just grab them all. Right. So, what have we got in this little box then? Well, we have a trio of transistors. Yep. And 3 of those and 2 of those. So yeah, we're looking at incredibly complicated things here. And we have a whole slew of diodes by the looks of things. 1N148, so yeah, common diodes. CD4017BE, same as in the other board that we did. That's the socket. NE555. Now these actually, the printing on this looks better than the chip on the other boards, so I would say that it's more likely to be a genuine Texas chip. And as we see, a whole handful of diodes, a capacitor. So just going by under a little pot. So just going by the bits that we've got here, this will control this capacitor here, which is a 50 volt 1 microfarad capacitor. That will be the timing capacitor for the 555 chip. That one will just be supply decoupling to take any noise off the supply line. The transistors, let me just see if I can see what they are. S8050. Sounds like a general purpose. Could be quite a high current, maybe about an amp. Just a general switching transistor. The diodes are standard diodes. Now we've got 2 different values of resistors here. we've got 2Ks and 2K2s by the looks of it. 10Ks. Oh, that's a bit strange. The board is marked for a 2K and a 2K2, but they've just given us two lots of 2Ks. Which are those two? 10Ks are these ones. Start 1 1 0 0 100. 2 zeros after it, which will give us the 10,000. Yep, and that's it. So we've got 3 10Ks, 2 2Ks. 2 2s. They're both 2.2Ks actually. So yeah, looks like it might affect the timing slightly on the 555, but not to any great degree, I would have thought. If it becomes a problem, we could always put in something different. We can always put a 2K in or 1K8, something along those lines. But really, it's the capacitor that does most of the timing on the 555. So let's put those two in there. 3 resistors. These just look like the base resistors on the 8050s, seeing as there's 3 of them and 3 transistors, so it would make sense that they're all for doing the same job really. What effectively you're doing is 3 identical circuits. First, because I can reach the leads better, and then that one. One for the first set of lights, one for the second, and one for the third set. So they're all the resistors. And let's turn the board down, sit it flat, get the melty thing, and do the lead melting. Just clean that off. Again, this board actually seems to be quite nice quality. Very clear printing, very good solder resist, the green solder resist with nice clear pads. Not too small, the holes have been drilled perfectly adequately. So that's those 3 resistors in. Missed one. There's always one, isn't there? There we go. Get all stuck to the bits. So what other discretes we got? We've got that one capacitor there. I think next, if we go with the transistors, reasonable. Right, okay, so Q1, again, I'm just assuming that this is the right way around for these, because obviously no circuit diagram has been supplied, so you're just going by the screen print. As I say, it's a nice clear print, so it's quite a straightforward one. Let's see where the sockets go in at the same time. The 555 goes in that way. There. Let's do the other corners now. Okay, transistors 1, 3. Okay, so let's do the rest of this bit of the board. Little 104 capacitor which goes across there. We've got the 10 microfarad capacitor which has actually got the positive marked on the board, which goes there, and the 50k pot which goes in there. Okay, so there we go. 1, 2, that lead's not quite in. The hole's slightly smaller than it really should be for the pot, but that's sitting not quite straight, so go and get in. There we go. Just a little wiggle, sit it down a bit. Right. So I think this will be the last bit of soldering. I'm going to move the empty bags out of the way because they have been nearly soldered a couple of times. So, yeah, all done there. So let's just plug the 555 in first. We can go there and there. So that's that. Let's just bend the pins down slightly on that. Make sure they're roughly in the right position. There we go. That's that. Right, so power. Right, okay. Yes, I could get the wire strippers out, but I'm going to just use my cutters. What I will do, I'll twist them and I'll put a blob of solder on the end just to sort of seal them up and make them a little bit of a... Come on. So that's power, and then let's just make sure that these all go the right way round. Red to plus, and on this it should say, let's just make sure they're commoned up, red to the output, the emitter of the transistor, sorry, base of the transistors going to the deck. That's it. Cause yeah, you know what I haven't soldered down? I haven't soldered down the pot because it sits there so small and right. So I didn't hear the camera click off, but there we go. So there we are, all finished. Everything plugged in. And as I say, normally on that chip we saw it counting 1 to 10. So what it's doing on here is we've got 1 flash on there, 2 flashes there, and 2 flashes there, so it's going in a loop, so some of the outputs are not being used. It's a case of working out. I could get the data sheet and pull it out, but yes, you can either slow it down or speed it up, right up. It's actually quite a usable range. I think that looks about right. And I think what I'll do is I shall turn the bench lights down. Just leaving the 2 spots there. And yeah, there we go. Oh, just as a final bit, you know, I said about running that LED strip instead of one of these boards. Just connect the live and the neutral up and the single flashes. There we go. Using the strip. So yes, you could use it to decorate something else. They don't have to be red, white and blue. They could be green, yellow and pink, or whichever colour LEDs you fancy. But yeah, there we go. Thanks for watching.